This is Professor Dare of Science. This video shows how to complete a hypothesis test for the population mean when sigma is known. First, you set up over here your null hypothesis and your alternative hypothesis. The null hypothesis always has the equality condition, in this case with the mean being 41. The alternative, if you click on that cell, you have three choices and drop down: less than, not equal to, or greater than. In this example, it's greater than. Whatever's in HA determines the type of test to use: a left tail, right tail, or two tails, depending on the less than, greater than, or not equal to condition, or critical values. Similarly, the left and right and two-tailed test also determined by the condition in the alternative hypothesis. The first blue cell input is 41. In this case, the hypothesized population mean. Alpha, the level of significance, is 5% in this example. N is 40. In order to use this kind of a test, your distribution must either be normal or n must be greater than or equal to 30. X bar, the sample mean from your sample. Sigma, the population standard deviation, which is assumed to be known for this kind of a test. The standardized test statistic here, there's the formula for it. It's X bar minus mu divided by sigma divided by the square root of n. Below it is a rounded version of the standardized test statistic, which is used in these calculations below, rounds it to 2 decimal places. The p-values rounded to 4, we have norm.s.dist, B8 and true. For the right tail, it's 1 minus B11. For the two tails, it's conditional. If B8 is less than 0, it uses 2 times B11, otherwise 2 times B12. And for the critical values, the left tail, these are rounded as well. Norm.s.inverse, B2. The right tail, norm.s.inverse, 1 minus B2. The right tail, the two-tailed test rather, the left tail of the two-tailed test, norm.s.inverse, B2 over 2, and the right tail of the two-tailed test is minus B18. Of course, you can see what each of those mean. To make your decision, you can use either the p-values or the critical values. They're equivalent. For the p-value way, you reject H0 if the probability of chance, the p-value, is less than or equal to the level of significance alpha. In the critical values rejection region method, you reject H0 if the test statistic Z falls in the rejection region.